what are the primitives that Modal provides to help you like build up these things? Like how do you define one of these cloud functions?
You just write a normal Python function and then you apply a decorator. And in that decorator, you define the runtime environment. So that's like basically what image it is. You can also define things like, do you need a GPU? Then you specify what GPU type. There's a bunch of other stuff. Like you can add like a cron syntax if you want the function to be automatically triggered certain times a day, or you can mount like file systems to it. So we have this ability in Modal to define essentially like an NFS equivalent and mount that to the containers locally, so you can set up like shared file systems and a few other different things. And then those functions are just normal Python functions, right? And you can in those functions you can call other functions. You can map over other functions, and then we automatically scale out. A couple of other things you can do, like you can set up secrets. So you can set up in the web interface in Modal, you can define like credentials, your AWS credentials or OpenAI keys or whatever. And then you can import them in Modal. You can annotate functions and say, I want to inject these as environment variables, and then you get them available as environment variables in runtime. So this way you don't have to like deal with hard-coded secrets in code. You just inject them in the cloud. What else? You can define things to be a webhook. So you can take a function in Modal and basically annotate it as, I want this to be a public webhook that's exposed to the world. And then Modal will then generate a random or a unique URL that you can then go to, and that will trigger that function. So those are some of the primitives we have in Modal. You can build quite powerful apps with.
Is this position more like a serverless framework in the sense that they're more for shorter running jobs? So you do like a shorter running process versus maybe more longer term living, maybe you're doing a really big analysis or something, sending that to a GPU. I guess like in that scenario, you might have like a server that is dedicated to this process or whatever. To reframe, is it shorter or longer running jobs that you're sort of aiming for?
I think we're like fairly unopinionated about that. Like Modal as a whole, like you can run things for up to 24 hours. But that being said, I think probably like it skews towards shorter running stuff. It tends to, I think the main reason is probably like one of the benefits of running things serverlessly is really cost. Like when you have, when you can autoscale to the actual usage. Like let's say you want to productionize a machine learning model and you don't know how much traffic you're going to get, right? Like with a traditional system like Kubernetes, like you essentially have to like, the system scales quite slowly, right? Like it doesn't scale within seconds. So you have to provision to some extent for peak capacity, right? Which means you're going to have like pretty low utilization rate. So where I think we've done like right now, where we see by far the most usage is like deploying Gen AI, like GPU-based models. Like GPUs are also expensive, so that's the other thing, right? Like people want to save money by running serverlessly. And so that I think that's like one of the biggest benefits that's evident with Modal right now is like people see, a lot of people may actually move from EC2 to Modal and end up saving a lot of money because they have this ability to auto-scale very quickly up and down usage. So for that reason, it tends to be shorter running things, like a couple of seconds, like typically like inference endpoints, like doing stable diffusion, that kind of stuff. But we have a lot of people also doing things like fine-tuning is getting more and more common. So an example of fine-tuning would be like Dream Booth, for instance. So like you can like basically like fine-tune this like custom stable diffusion model based on like pictures of you or whatever, like pictures of your kids or your dogs or whatever. And then you can generate like, stable diffusion pictures of your dog or whatever. And that fine-tuning process often takes like 30 minutes. So that's something people do quite a lot with Modal. Like they'll have this like thing running for 30, 40 minutes on Modal, on A100s or something like that. We also have some people doing training with Modal. So in that case, like you might actually have like things running for like several hours or days. Because I think you can actually, I said 24 hours, but I believe you can actually extend it to 7 days. I forget what our upper limit is. So we have some people running it for much longer than that. But yeah, I'd say the median is probably like 5 seconds.
Yeah, that's much longer than most other serverless platforms where you're like capped at 20 seconds. Can't do too many interesting things in 20 seconds. I think
exactly.
The auto scaling is a huge point. Like when I was comparing platforms, it's like I come from a front end JavaScript world. I have never had to run a GPU before. And running a GPU for a month all the time is like $500-$600. So like the ability to like be an indie hacker and say, oh, I want to put this model somewhere and only have it spin up when I need it to spin up is super powerful.
Totally. And if it goes viral, we'll scale. You know?
Exactly. Yeah. And I like all the features you guys have for like, oh, like maybe have this run for like 3 minutes after the last request, or keep like 1 or 2 of these always on. So it's very nice and very like flexible to the needs of the developer.
Yeah. Now the problem, I think, on the technical side, just because I think it's interesting to talk about with doing serverless GPU is the cold start, right? Because in order to do these models serverlessly, you need to spin up the containers very quickly, like on demand. Like a user request comes in, now you need to spin up a container very quickly. And that's a problem in itself just for CPU-based functions. Like Lambda has solved it clearly. Like they can spin up containers very quickly. But when you're dealing with GPU models, suddenly it's a much bigger problem, because like some of these GPU models, like just starting with Stable Diffusion, that's 5 gigabytes. So you need to take something that's 5 gigabytes large. You know, like with Kubernetes, it's like brutal, right? Like you need to pull down a Docker container, then like, you know, start up the container. Then that one has to read like, 5 gigabytes from network into memory, and then, you know, copy it from memory to GPU. So that's like, a minute or 2, right? But with Modal, we ended up building our own file system. We built building our own container runtime, our own container image builder. And so because of that, we can do something similar in just about 10 seconds, like starting a container, loading the 5 gigabyte model files like from network into CPU memory, and then copy it from CPU memory to GPU memory. I hope to get that down to a couple of seconds eventually. There's clearly, 5 seconds or 10 seconds or whatever it takes is still a long time. And it's as a noticeable latency. And it gets even worse for some of these like very large like language models, right? Like you have these language models that are like 40 gigabytes, right? But those are some of the very super interesting technical challenges we're dealing with. Is how do you load these very large models into GPU memory very quickly in a distributed system?
So do you guys like? I don't think you guys actually like own the hardware, right? Like who actually owns these GPUs?
Yeah. We didn't go that deep. Like,
yeah,
we do run this on the hyperscaler, the public clouds, right? Like in particular, Oracle has good GPUs. We run this on AWS and GCP as well for some burst capacity. We haven't gone quite as deep as building our own hardware. I think that's a bridge I'm not sure if we're ever going to cross. Maybe one day, but everything down to that point, right? Like we've done a lot of just like performance tuning Linux kernels, and like there's a lot of like deep stuff that we had to do in order to get to the performance we wanted.
Yeah, I think just working at Oxide has taught me this lesson where if you step outside of the sort of composed software and even hardware components that you're putting together and think more critically about what is the holistic problem you're trying to solve, you can often come up with solutions that are much more performant, because there are all these trade-offs at all these layers in general composable software. You got Kubernetes and you've got Docker and all these things, and they're meant for a specific use case. And, maybe this use case is non-optimal. And
I always think about this, there's modern computing has so many abstraction layers on top of abstraction layers on top of abstraction layers, right? And every abstraction layer usually adds an order of magnitude of overhead. And so why is it that when I go into AWS, computers do a billion or a trillion floating point operations a second. But when I go into AWS and I update some load balancer setting, it takes 25 minutes sometimes for it to propagate, right? Why? But I think the solution is there's so many different layers of abstraction that they're all relying on cache invalidation or TTLs or so many different things that all just add up, and that's why we end up having this slow stuff, right? But a lot of these things, if you actually push through, you can actually figure out ways to make it 100 times, 1,000 times faster than what people think. Not always, of course. I mean, there are fundamental limits. Network bandwidth is hard. Once you saturate what a network interface can do, it's hard to get around that. But a lot of stuff is how fast should a container start? I don't know. I don't see a reason why it shouldn't start in a few milliseconds.